is we're going to review this trigonometry stuff, and when I go through it, some of you will be like, whoa, slow down. And some of you will be like, all right, this is good, because everybody has their strengths and everyone has things that they're working toward being stronger, right? So whatever pace it is, I'm recording this. You can watch it again, okay? There are pause buttons on computers, as you know, so you can pause it and do whatever work at whatever speed you want, but I want to be able to go through this at the rate at which I would like you to be able to solve these problems. Okay? So, first thing we're going to look at is page 1-3. So you can just pull out your books and get to page 1-3. Please and thank you. Do we need the light today on this? Light. No light. Oh, what am I doing? Duh. Guys, you're supposed... No, I thought this button meant light. You guys have to help me. You know I'm old and I forget things. Why? Because it's fun. It's calm. It's like, oh, let's see Miss Weinrib forget 16,033 33rd thing of the year, of the semester. Oh, you guys are having a laugh at my expense. I love that. I got to tell you guys something. No matter what happens to you in life, don't ever lose your sense of humor. Got that? Lesson number 1,000. Okay, so we're going to have, let's do a quick overview in our minds about what trigonometry we need to know. We need to know SOHCAHTOA. We need to know that sine is the opposite side, the sine of an angle. I'm going to write as I go. You guys just watch. You don't have to write this. When we have right-angled triangles, we always, under no conditions do we do anything else. This is not one of those I before E's except after C's. It is always the case that we always, with trigonometry, start with the angle. So I'll just call it theta in honor of the Greeks who figured all this stuff out. Okay? So from the angle, you will know what side is opposite, what side is adjacent, and of course, the side that is opposite, the right angle, is always the hypotenuse. Okay, always no exceptions. Start at the angle to know what is opposite and what is adjacent. Okay? We will look at doing pure math, which you know is just like crunching numbers, versus applied math, which is applying things to real life situations. Okay? We will do this with right angled triangles, where we will use SOHCAHTOA to solve these problems. And then we will do it with non-right angled triangles, where we will use sine law or cosine law, depending on the information that's given. Is it your birthday? Whose birthday is it? Your boyfriend's. It's so nice. Look at all those balloons, and so nice. What's your boyfriend's name? Balak? Malik. All right, very cool. Okay. So we're going to be doing, come in and sit down and say nothing. Thank you. Okay, so we're going to be doing trigonometry, right angles, SOHCAHTOA, and then with word problems, and then non-right angle triangle solving, which will be with the sine or cosine law, depending on what we're given, and then word problems with that. And that's what we need to be able to do in this course with trigonometry. So, there's going to be 4 things I'm going to say again. I want you to give yourself a rating 1 out of 10. Where 1 is, I sort of remember a tiny little bit, and 10 is, if Miss Weinrib needs an assistant when she's away, I can teach at the board. Okay? So, doing SOHCAHTOA with no word problems. Pick your number. Don't tell me, tell yourself. What's your number? Next, SOHCAHTOA word problems. What's your number? Next, sine and cosine law. With no word problems, just find this angle, find the length, or solve the triangle, which means find all side lengths and all angles. Pisa, will you do me a favor? Will you shut that door, please? Thank you so much, because I'm wired up here, ready for takeoff. And then lastly, what's your number? Thanks, Visa. From 1 to 10, where you are going to do word problems with sine or cosine law. Oh, I have another one for you to give a number for yourself, 1 out of 10. If you're given just the length, the writing in English, being able to draw the diagram, the triangle with the angles and the side lengths at the right spot. What's your number? Okay? So now, here's what we need to do. We need to figure out for all 5 of those categories. Well, we don't actually have to figure it out because we know how to get better at all of them. It's just do more questions. And tied to doing more questions is asking when you don't know what to do. Now here's the thing. When you ask something, you have to first, if you want to ask the best question, the question that first comes to your mind, you ask, and then you see if you can answer it yourself. If you can't, then ask someone else. Because have you ever had a situation where you ask a question, then as soon as it comes out of your mouth, you can answer it? So, do that. You answer your own questions. Think of the questions, see if you can answer it, and if you can't, then really think about exactly what you want to ask, so you're communicating really clearly about what you want to say, and then ask it. So, having said all of that, let's take a look at a couple of questions, not a couple of questions, a bunch of questions. So first question I'm going to give you is, hang on a second. First question I'm going to give, please hold. An operator will be right with you. Okay. And with SOHCAHTOA, we know that we have to use a calculator sometimes because we might be given a question where we have to use that sine to the -1, the inverse part. We'll talk about that in a second. First, let's do this. If you want to know where the heck is, okay, let's do this. First of all, where do we start again? At the angle. We always start at the angle. So we always say, number 1, where do we start? At the angle. Number 2, what's given? And number 3, what are we looking for? So from this angle, what is given? Opposite, adjacent, or hypotenuse? This is opposite, and what we're looking for is, and which trig ratio has opposite and adjacent? Which one? Opposite and adjacent. Which one has OA? So then the tan, or tangent, but the tan of 63 is opposite over adjacent. Opposite over adjacent, or adjacent over hypotenuse, or opposite over hypotenuse, right? So then we have to solve. So we know that we can cross multiply when we have a proportion, which is 2 fractions separated by an equal sign. If you want to make something a fraction, you just put it over 1. So we have x times tan 63 degrees equals 5 times 1. And then we want to get x on its own, so we divide both sides by whatever x is multiplied by. So we have x equals this over this, and yes, that is for calculator use. And remember, you have to know how to use your calculator. So if you need to do in your calculator 5 bracket 10 63 close bracket equals, then do that. If you need to do 5 bracket, sorry, what did I forget to do? Divide. 5 divided by, sometimes you do 30, why am I doing that? 63, 10 equals. Again, it depends on your calculator how you input this stuff. You have to know your calculator. If anyone doesn't know their calculator, please don't ask me on the day of the exam. Ask me now, or tomorrow, or the next day while we're reviewing. Okay, next question is, let's say we want to find this. Never mind that, we just did 10. Let's do this. So I'll put my theta there. So 1 is start at the angle. 2 is what's given? Opposite, adjacent, or hypotenuse. What are we looking for? What trig ratio? Sine. So sine theta equals y over 3. Or is it 3 over y? Y over 3 or 3 over y? Y over 3. Okay, so this could be a communication question. This could be, why can you not, pourquoi, why can you not solve this? Why can't you solve this? Yeah, they've got 2 unknowns. Can't do that. So you would write, can't solve with 2 unknowns. Okay? So let's say we now have this, and we don't have 2 unknowns. Are we going to use sine, cos, or tan here? Yeah, because it's still opposite and hypotenuse, right? So we've got the sine of theta equals 2 over 3 or 3 over 2? 2 over 3. And here's when we're given, here we were given the angle and not knowing a side. Here we're given 2 sides and not knowing the angle. So this is when we have to do the flip-flop of these two. So we've got theta equals sine inverse of this, and then we plug that into our calculator. Yeah.
I was practicing here. I was noticing that, like, in some questions, I flipped the fraction, so it would be like 3 over 2.
Okay, you'll have to show me.
I don't know why I did that, but like it was.
I'll come take a look at it shortly. Don't let me forget, okay? So now you have to punch this in your calculator. Again, I can't do this in my head. And if I can, please be sure to call me a freak. No, seriously. Plug this in and you get your answer. Bless you. Okay? Is everyone good? Okay, let's try another one. Okay, let's say we have there we go. So we have to start at the angle. What are we looking? What are we given? Did I do something wrong? Oh, I thought I heard a whisper of some kind, like, oh, she did it again or something. Okay, just kidding. I'm just teasing with you guys. Teasing you guys. Okay, so start at the angle. It's 15. Is 5 opposite, adjacent, or hypotenuse? And x is? So we're using which ratio? Cosine. So the cos of the angle is adjacent over hypotenuse. Again, we're going to cross multiply, so that's 1 times x, of course, is x, and 5 cos 15 is whatever cos 15 times 5 is in your calculator, right? Okay, so you can see here, when the unknown is in the numerator, it's a little bit easier to solve for it than when the unknown is in the denominator. We had to cross multiply and then divide. It's not such a big deal, but I just want to bring it to your attention. Okay? Who's got a question about any of this? Anything at all? Please ask, bless you. Because if you have a question, you can be sure someone else has a question, and that's the way it's going to be. Okay, so now we're going to try a question, a word problem question. So let's say we have a flag. So I'm going to read it, and I want you to write the diagram as we do it. Okay, so we'll call this the flag problem. A flagpole, where am I? A flagpole casts a shadow of 28 meters when the sun's rays make an angle of 25 degrees with the ground. How tall is the flagpole to the nearest meter? So we have a flagpole, pardon my art. We have a flagpole. Now, when you're standing outside and you see a shadow, is your shadow on the ground, in the air? Where's your shadow? On the ground. Your shadows are on the ground. Please don't pretend that you don't know where shadows are. You know shadows are on the ground. So we've got here, the flagpole casts a shadow of, so here's the flagpole. Obviously the sun's up here in the sky, and the flagpole has a shadow here, and it's 28 meters. Any questions about that? Okay. Now, this happens when the sun's rays make an angle of 25 degrees with the ground. So I'm going to call this A, I'm going to call this B, and I'm going to call this C. Where is the ray, the line that the ray of sun makes? Is it A, B, or C? It's C. You know that you see them in the sky, these angles coming down. So this is the ray. I'll just put it there. You don't have to, but I'm putting it there just to help you guys out. And the angle that the ray makes with the ground is 25 degrees. Does the angle go in position 1 or position 2? Is the angle here or here, the angle between the ray and the ground? 1 or 2? 1. Here's the ground, here's the ray, the angle that's made is 25 degrees. Right? And they want you to find out how tall is the flagpole. So, do they want you to find out A, B, or C? B. So here, now that we've sort of roughed out this and talked it through, if you want to draw it again to just have the information that you want without any units and stuff like that, then there you go, right? If this is too busy for you to look at that you're writing as you figure it out, then just write it again. Heck is going on here? Okay, then just write it again. Okay, so now we start at the angle, which is 25. What's given? Opposite, adjacent, or hypotenuse? What are we looking for? Opposite, adjacent, or hypotenuse? What trig ratio is opposite and adjacent? Tan. So tan 25 is opposite over adjacent. And then we do our little cross. Then we're back to where we just did. We've got 1 times b is b, and 28 times tan 25 is whatever your calculator tells you it is when you press the buttons correctly. Right? No piano playing on the calculators, guys. Okay, now, When we're given a word problem, do we have to write a final sentence? Yeah, we do. But it does not need to be something that's going to wow the head of the English department with all sorts of adjectives and fancy words. Just say what you want to communicate. So if the question says, how tall is the flagpole? You will say, the flagpole is, therefore the flagpole is whatever the meters is when we plug this into our calculator. All good? Excellent. Okay. So next, what I want to do is I want to take a look at the sine and cos law. So sine and cos law are used in very specific situations. So let's just draw a triangle that is clearly not a right angle triangle. And we're going to write down when we use cosine law and when we use sine law. So there are 4 scenarios, 1, 2, 3, and 4. One of the scenarios is when we are given 2 angles and any old side. So it could be these 2 angles and this side, these 2 angles this side, these 2 angles this side, or these 2 angles this side, these 2 angles this side. It doesn't matter. Any combination. When you're given 2 angles and a side, you use the sine law. Okay? When you are given when you are given 3 sides, so you're given this side, this side, this side, and no angles. You're given 3 sides, no angles, you're going to use the cosine law. And then the third scenario, which kind of has 2 branches, is when you're given 2 sides and an angle. So when you're given 2 sides and an angle, it depends which angle and which side. Okay? So these 2 are both 2 sides and an angle. So when you're given 2 sides and an angle, you have to look and see what is given where. Meaning, when you are given, I'm just going to call this ABC, and then of course this will be A, the side opposite B is B, and the side opposite C is C. Vertices or corners of the triangle are all capital letters, side lengths are always small letters. That's how you know when you're given a small or a big letter, if it's a side or an angle. Okay? So when you are given 2 sides and the angle you are given is not the angle that those 2 sides make, in math we say it's not, this angle is contained by these 2 sides. So when you're given 2 sides, and here the angle is in between the 2 sides, but here the angle is not. So if you were given side A and C, and then angle A or C, in other words, not angle B, which is contained by these 2 sides, you use the sine law. And when you are given 2 sides and the angle contained between those 2 sides, you use the cosine law. So I'm going to now ask you, seriously? Don't they know we're in the middle of filming a movie? Alliance Films, may I help you? Hi, what's up? No, I'm afraid he's not here today. Thank you, bye. Okay. So, when we are, So I'm going to now ask you guys a couple questions. Yes?
If the angle is not contained, then you use sine.
Correct. So I'm going to give some
If
examples.
it's contained, you use cosine.
Yes, ma'am. Mister. Sorry, what am I saying? Yes, ma'am. Hello. Not even thinking properly. Okay. So, let me ask you first, does anyone else have a question or just about what I've written? No? Okay, so now I'm going to give you some examples. Bella, you're starting. Boyfriend, birthday girl starting. So Bella, if I give you side angle B and angle C and side A, am I doing scenario 8, 1, 2, 3, or 4? So I'm giving angle B,
Oh, sorry, one.
angle C, and side A. Good. So I'll use which law?
Side.
Excellent. Adam, you're up. You're up at base. You're at home plate. You've got the bat. Are you ready for the pitch? Okay, good stuff. If I give you angle B and angle A and side B, scenario 1, 2, 3, or 4. Angle B, angle A, and side B. Sine law, but is it scenario 1, 2, 3, or 4? Perfect. Good. Fiza, you're up. If I give you side A, side B, and angle B, is it scenario 1, 2, 3, or 4? So two sides and the angle is not the angle that side B and A make. Perfect. Okay. Usama, I'm going in a swirl. Osama, then Jada, then Carla. So Usama, if I give you side A, side B, and angle C, is it scenario 1, 2, 3, or 4? So I've got side A, side B, and angle C. Scenario 3, because the two sides make up that angle that's given. Okay? Excellent. Jada, if I give you side A, side B, and side C, what scenario do we have? 4. So what law? Excellent. Carla, I'm giving you a trick question because I know you love me so much and you'll let me do this. If I give you angle A, angle B, and angle C, what law do you use? No, angle A, angle B, angle C. What do we use for 3 angles? None! You can't solve the triangle if you're given 3 angles. You must be given at least one side. So I could ask you a communication question. You better be listening, lady. Put that rectangle down right now, miss. Okay. If I give you a question and it says, true or false, in order to use sine or cosine law, you must have at least one side. Or true or false, when given 3 angles, you can use the sine law, right? As in correct, I could give you questions like that. They're called thinking. You have to think about what you know and then answer the question. You're not just robotically regurgitating, oh, she's given us a whole bunch of questions like this, here's another one, I do this. You need to think. Every single person in this class is capable of that kind of thinking. Even if I'm, between you and me, are the only person who believes that. I know you are all capable of thinking that way. So what you do with that comment is you do not say, she thinks it, but I can't do that, freak out, and then not be able to study for the exam. What you do is you say, she believes in me, she knows more than I do in math, so she must know, and okay, I'll just keep working. That's the way it goes, okay? So now let's take a look at doing some of this sine law and cosine law stuff. So we know that sine law is the sine of A over angle A over side A equals sine angle B over side B equals side of angle C over side C. And you will be using 2, either these 2 or these 2 or these 2. You'll be filling in everything that's given, everything that's you're looking for, and you will take 2 fractions, equate them so that they're a proportion like this, let's say. I'm making up numbers, obviously. And you will say, okay, when I equate these two fractions, I have one unknown. We already talked about what to do if we have more than one unknown. You can't do it. I have one unknown, and now I'm going to cross multiply and solve for it. Okay? If you have a fraction and you let this equal, let's say this, you can't cross multiply and solve. There's two unknowns. So that's how you'll know if you've set your fractions up correctly, is you'll say, oh, I can't solve it. So the situation is not, I can't solve it, I'm a dummy, I can't do this. The situation is, I can't solve it, I better find two more fractions that equal each other that only has one unknown in the whole situation. Right, Bella? All right, good. If you are using, not if, because definitely it's not if, it's when, you will be using cosine law. The cosine law, you know, is a squared equals b squared plus c squared, so it looks like Pythagorean theorem. And then it's minus two of these, 2 of bc, and then the cos, let me make that a big C so it doesn't look like a variable, cos of that angle. So it's like bookends, A. So if you had b squared, it would look like a, the other two, minus 2 of whatever that is there, cos of that angle. And this one will be a squared plus b squared minus 2 of these, and then the cos of whatever's over here. And then you just plug the stuff in and solve it using collecting like terms, multiplying, bed mass, dividing both sides. You know, if you have 3x equals 6, you divide both sides by 3 to get what x equals. All of that's algebra and arithmetic stuff that we've been doing for years. You apply here. That's what we do. There is another formula for cosine law if you want. And what it is it's just moving this formula around. So you know how if you have this, you can do this, right? So what you do is you bring this whole thing, negative 2ab cos c, you bring it over to this side, so it's positive 2ab cos c, and you leave these two here, and you bring this over, so if it's positive here, it's negative here, you know what I mean? And then you divide both sides by 2ab, and you get what cos c equals, and that's the other formula. So it's really just manipulating this one. So if you want, you can memorize all of them, but you don't have to, because you can always just plug everything in here, even if you're not looking for C or B or A, and then just move it around with this stuff. Or you can memorize these. Both are totally fine with me. Okay? So now let's do a word problem with this kind of triangle. So let's see here. What the heck am I looking at here? Okay, so plot of land. What am I doing? Jeez. The English teachers would be mortified if they saw my lessons, wouldn't you say? All right, plot of land. So we have a plot of land. It looks like this. Don't ask me who would really buy it, but let's just do the question anyhow. That angle is 74 degrees, that angle is 48 degrees, and let's say this is point A, this is point B, this is point C. I'm only circling them because it was so close to plot. I didn't want you to think it was called plotta. And this distance from A to B is 90 meters. So the question says, calculate the perimeter of the plot of land. So we have to think, because it's not just saying find all the angles, find all the sides. We're not doing pure math here, we're applying it, we're thinking. This is land, You have a triangular piece of land. We want to know the perimeter because we're going to go buy some fence, let's say. Okay, that's a real life situation. People put fence around their properties. So we need to buy fence. We need to know what the perimeter in meters is. Let's do that. So what if we're looking for perimeter, what do we need to do? What do we need to do? Usama, do you know? No. Carla, do you know? Do you have a guess? Bella, what do you think we need to do? We want, first of all, who knows what perimeter is? So if you know what perimeter is, you know why you don't know how to do this? You're not thinking hard enough. Are you kidding me again? Now I'm answering. Hold on to your thought. Grand Central Station, may I help you? No, come on in. Okay, bye. Miss Kay needs to come in to get a binder, and she's so polite she pulls first. Never done that. Okay, so we have this plot of land. We want to find the perimeter. Well, what's the perimeter of this square? If this is side X, and this is side X, and this is side X, and this is side X, what's the perimeter of that square? X plus X plus X plus X? So what's the perimeter? If this here, let me draw this triangle again. If this is angle A, and this is angle B, and this is angle C, and this is 48 degrees, and this is 74 degrees, and this is 90, I won't put the units in right now, and this is, can I call this side A and this side B, and we know side C is 90? Then what is the perimeter? If this is the perimeter of this is X plus X plus X plus X, what's the perimeter of this? 90 plus A plus B. So the perimeter here is 90 meters plus, we'll use that in our final sentence, plus A plus B. So how are we going to find side length A, and how are we going to find side length B? How are we going to do that? Well, let's see here. When we are looking at side length A, first of all, we know that this is not a right angle triangle. Can we agree on that? For sure. So how do we know? We open our eyelids and our eyeballs will tell us this. Come on in, just come in, just walk. Come get whatever you need. Tell me, what do you need? This? Anything else? Okay. No problem. Leave $5 on my desk for the interruption fee. I don't know why she thinks I'm kidding. Hello, Internet land. Okay. So how are we going to find the length of A? Well, let's take a look up here. When we look at side length A, we need to find out, do we have two sides and an angle that are given? Do we have two angles and a side? Do we have three sides? What's given in this triangle? Is it scenario 1, 2, 3, or 4? Scenario 1, so what law are we going to use? Sine. So let's do that. We've got sine A over A, because we're looking for A, aren't we? And then, oh, wait a minute. I know what A is, don't I? Well, actually, let me do it this way. This is what I'm going to do. I'm going to go to a new piece of paper because I'm running out of room. First things first. So I'm going to, let's kibosh that and go over here. Sine A over A, sine B over B, and sine C over C. So we have determined we're using the sine law, so I write it out, and then I fill in what I know. Do I know angle A? What is it? So I've got sine 48 over, do I know side A? No. Do I know angle B? What is it? 74. Do I know side B? No. Do I know angle C? No. Do I know side C? What is it? 90. So now what we do is we look to see which two fractions can we equate and make a proportion where we have only one unknown. Is it possible yet? No, because there's no fraction that has known in both pieces, right? The numerator and denominator. So let's take a look. We've been talking about the sides, but we have to also look at the angles. So let me ask you something. We know that in order to find side A and B, we need to use sine or cosine law. How about to find angle C? What do we do to do that? Yeah, 180 minus 74 minus 48. So that's long before you met me, you knew that. So let's do that. 180 minus 74 is 60. Is that right? Okay, and then I also have to subtract 48, right? So now, 10, that makes that a 9. 16 minus 8, and 9 minus 5 is 58. So now I can do this, can't I? Isn't that right? I can do that? Okay, so now do I have a fraction where there's both, everything's known? So if I make these two equal to each other and I get rid of this, can I cross multiply and solve for B?
Yes.
And if I make the two outside ones, this one and this one, equal each other, can I cross multiply and solve for A? So now we know what to do. Now when we find A and when we find B, are we done? No, because the question was, what's the perimeter? So at the end, what do I need to do? Add all the sides up and write a sentence saying, therefore the perimeter is whatever I found, meters. Right? Okay. So I'm not going to finish this now because what I'm going to do is I'm going to finish this off screen, and so you guys can't see, and then you guys are going to solve it, and then you guys are going to check with me and see if you did it correctly. Okay? So, what we haven't yet done is solving with just plugging in things for cos law. So let's do that. Let's say you're told that, actually I don't want to do this like this. I'm going to do this another time. Scratch that. It's going to be better a different way. So that's what you need to know from your trigonometry chapter. Okay?